Hi, ladies and gentlemen. This is Mr. Green again, and this is another in my series of Algebra 2 lessons. And we are moving through Unit 2. We have done all the way through Unit 2.06. We are looking at 2.07. And 2.07 starts a brand new topic, and I just want to make certain we spend a lot of time on this. Due dates, after 28 days, things become locked and you can't get into it. In case you haven't noticed, second semester of Algebra 2, we slow down a lot. I'm spreading these things out, and we're covering an entire semester, but we're only doing a few chapters in this whole course because those are the ones that are necessary for what we do in Texas. But we have slowed down a lot because we want you to spend a lot of time working on this stuff and making certain you understand it. This is not just done for math purposes. You're going to be using some of the stuff in higher orders as you go along, and I want to make certain you're really understanding these topics well. So we have slowed down considerably. We're in 2.07 right at the moment, and it talks about logarithms. Now, you know what? In math, we deal a lot with opposites. You've got your plus, and the opposite operation is a minus. You've got your multiplication, and the opposite operation is a divide. And you've got your things being taken the squared, x squared, and the opposite operation is the square root of x, right? These are the opposite operations of each other. They just convert one to the other. The question becomes, what do I do to find x if it's the exponent? And that's what we're going to have to look at logarithms to do for us, okay? There's a way to use these to be the opposite operation of something raised to the x power. So it is converting something to something that we can solve. That's why you will have seen these. You know what? Our calculator has a button on it called log. We'll use that, and it will be very useful, okay? A logarithm of a with a base of b, in other words, b times log a, or log b a, where b is greater than or equal to 0 and b is not equal to 1, a is greater than 0, is defined as log ba is equal to x. What you're saying here is, what is the value of x of some base to equal this value? So right here, what is the value of x to raise 2 to that x power to equal 10. It's not a simple operation. There is a method of going through this to get it, okay? So let me go through and show you some of the operations that we're going to do. First of all, we need to be able to convert from exponential form to logarithmic form, okay? This is not just a simple conversion. Well, it is a simple conversion. You just have to know where the values go. This 2, if I'm raising 2 to the 4th power, that 2 is the base down here. See that log 2? That's where we need to have that. This 4, that's what we were looking for. And so that's what goes out here in the equals to side. And this 16, we're actually asking, what am I raising 2 to get 16? And that'd be equal to 4. That's how you work on these problems. That's how you convert them. So if I'm converting 5 squared is equal to 25, well, that's going to be log of base 5. Where am I getting the base 5? Well, that's what we're raising to the power. And that's of 25, and that's equal to 2. Okay? So even if it's negative, you can still do the same thing. Log 4, base 4, because that's what the base is here. And that's going to be equal to negative 3 of 1 over 64. It's that easy. It's really just a matter of writing them down a lot of times, okay? In this case, our base is 81. So log of base 81, equals 1/2, 9. So what do I raise 81 to equal 9? And the answer is 1/2. Okay? This last one, log base 10 of 1 equal to 0. What do I raise 10 to equal 1? And I raise it to the 0th power. That's the way you're reading those. Okay? There are some properties. There are some things that we can do with this. You're going to get a lot of experience working with these, working the problems, and so forth. The product property works a lot like the exponents. If you've got something inside of the base, so log base something, multiplied two things together, that's actually equal to adding them, the logs together. So I could say log base m plus log base n. Those two would work very easily. The quotient property, if I've got it dividing, I'm subtracting their logs. Okay? If I've got something being raised to a power inside of the log, that actually comes out as a coefficient. So p times log base n, m. And even if it is a negative, it's still 1 over, it becomes a 1 over p or dividing by it. Okay? These properties, you just have to get used to them. You might as well print this page out, save this page, because quite honestly, you're going to use these properties a lot. Okay? Let's look at a couple of them. Log 3, 8 plus log 3, 4. They want me to write that as a single logarithm. Well, since my bases are the same and we're adding them, that means we multiply them together. So log 3, and that would be 8 times 4. Well, 8 times 4 is 32, so that's going to be equal to log 3 of 32. That's a single logarithm. Looking at this one, I've got log 4s and base 4s in every one of these, so I'll be able to multiply these together. First of all, I see this coefficient. I'm going to move that as an exponent over that 2. Okay, so that's going to be log 4 of 2 to the 3rd power, or 8. Now I've got a minus and a plus sign here, so I'm going to rewrite the whole thing as log 4 10 divided by 5, and then plus 3, that'd be plus times 8. Well, that's 2 times 8, that's 16. So what are we going to get there? We're going to get log 4 of 16, and that's going to be my single simplified logarithm there. Remember, we're trying to ask, what do I have to raise 4 to give me a result of 16? This is actually going to be equal to 4. I'm sorry, 2. Because I raised 4 to the 2nd power to get 16. 4 times 4 is 16. Right? So looking up here, what do I raise 3 to get 32? Well, that's not as obvious, is it? Well, 3 times 3 is 9, times 2 is 27. It's not as an exact answer there, right? Not something I can do in my head. That's something we got to use our calculator for. Speaking of which, can we use our calculator to do that? No, we can't. Not directly. Why not? Because see how I've got this log here? That's actually log of base 10. If I use that one on this base 3, I won't get the right answer. Was there some way to change that? Yes, there is, as a matter of fact. What we have to do is do a little manipulation, and we'll do that in just a minute. First of all, I want to use the calculator and calculate some of these just to show you how they work. Log 8. Log 8 is you just press the log and you press 8 and you close the parenthesis there and you get it. It's 90308, 903.903. Okay? So what that's saying is, what do I raise 10 to get 8? If I raise 10 to the 0.903 value, let's try that. 10 raised to the 0.903, I should get pretty close to 8. See how that worked? Okay, this other one, it says LN53. Well, there is an LN button here. LN53, you press that, and get an answer, it's 0.397. So the question is, what does that ln mean? ln is using a base that's called a natural logarithm. It's using a value of a set number that is called e. That's all it is the value of e. And you're going, well, what is e? Well, you know what? Your calculator will actually show you that if you raise e to the first power, you get e, and it's 2.71821828. This is an irrational number. It's a lot like pi. It's one that you would need to have out there. But since the calculator has it already for you, it's a nice, easy one to use. That's a base that you're not going to see. But you know what? It's the natural logarithm. It's the base that a lot of things in nature are based off of. You will use it a lot. So the question becomes, if our calculator only does base 10 and natural logarithms, and that question I was just asking you before, how do we convert from one logarithm to another logarithm? Well, we actually can do that. If I've got any logarithm, log BA is equal to some x, right? I'm going to rewrite that in an exponential form. I'm going to say a is equal to b to the x power. That's what it is. Base raised to that x power is equal to a. Now, if I take the log of whatever base I'm wanting to convert to on both sides, go away, thank you, and it says log n of b to the x power, log n of a. I know b to the x power, I can say x times log n to the bth power. I can divide by this. X is equal to log NA divided by log NB. And that's what X is. Wait a second, we had X up here as this. Substitute, take this, substitute it in right there. And I get log BA is equal to log NA divided by log NB. This is what you can do to convert, okay? And I'm giving you the conversion there. So if I've got log of some base of a value, I can take log 10 of that value divided by log 10 of that base, and it will give me the answer. So let's back up here. We had log 332. I can actually rewrite that as log 32 divided by log 3. And what I'm doing is I'm actually saying base 10 here. Now that's something we can do on the calculator. We can press log 32, close parenthesis, divided by log 3, press close parenthesis there, and hit enter, and it gives me a value, 3.15. I didn't write any more decimals than that, 46, so that works, 3.15. Can you see how we can do that now? That becomes a useful trick. Does it make a difference if we're doing log or natural log? Not at all. And I want to prove that with this one here. Well, I'm going to rewrite this one as log 20 divided by log 5. That's the conversion to convert it to base 10, right? And this is going to give me some value. I want to compare that value to the natural log 20 divided by the natural log of 5. Okay? And see what value we get there. So first of all, move over to the other side. Thank you. Log 20 parenthesis divided by log 5 parenthesis. And what do I get? I get 1.8613. 1.8613. Is that right? 135. So 4. They wanted it to 4 decimal places. So there's the answer to this question. But let's look at it from a natural log perspective. ln 20, close parenthesis, divided by ln 5, close parenthesis, hit enter. And what do we get? 1.8614. Same value. So does it matter if I'm using ln or if I'm using log base 10? No. When we're doing this conversion, it's right here. When we convert from one to the other, it doesn't make any difference whether I'm converting to base 10 or if I'm converting to base natural log. This conversion works every time. If it's something to some base other than 10 or e natural log, you can convert it to them by actually dividing. Okay? That's where this comes into play. I appreciate the fact that you guys do tell me that you're in Algebra 2. If you do, it helps me find your information quicker and get you answers quicker. I'm looking forward to seeing you in tutoring. I'm looking forward to seeing you in Class Connect next time. If you've got questions, bring them. Don't forget to work the problems in the assignments, because working those problems will help you understand this material. I look forward to it. See you next time.